ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I am glad you joined me this evening. Tonight's homework is for the evening of February 22nd, 2018, and we're looking at a few more composite shapes. Let's get started. Alright, let's look at number 8. We have a half circle, a square, and then another half circle. And our strategies stay the same. We're going to split our shape. Now, if you notice, I have two places that I've highlighted here. The reason I've done that is because I don't see two different shapes. I see one shape. So we'll talk about that in a few seconds. And this is my first shape. The second shape is this square sitting in the middle. 7 meters at the top, 7 meters down the side. That's a square. And here's why I see it as two shapes. If I take that square out of the middle and I slide that other half circle over, do you see now why I say that's one shape? We have a circle and a square. And all we're going to do is find the area of each one and add them up. So let's find our measurements. As it turns out, we have just about everything we need. Pi times r squared is going to be our area formula for our circle. And for a square, of course, it's just side squared, or a times a. Side squared, okay. So going back, pi times r squared. Now, what is our radius? The reason I said we have everything we need is because when we look at pi, we know that what that is. That's 3.14. But here's our 3.5. 7 divided by 2 is 3.5. And a radius is just half of the diameter. So if they give us a diameter, they have also given us the radius, because all you have to do is divide it by 2. So pi times r squared. Don't use the entire diameter. So 3.14 times 3.5 squared. Now, that becomes 3.14 times 12.25, and we end up with 38.465. That's going to be our area for this circle. Now for our square, we have just simply side squared, or a squared. Our a is going to be 7, and 7 squared is 49. Let's add them both up, and we get 87.465. And we just need the nearest 10, so we're going to call that 87.5 meters squared. That's it for number 8. Number 9, we have here a shape, and it's a shape that has 1, 2, 3. It's got 4 sides on it. It's some kind of quadrilateral, but it's an irregular quadrilateral. So what are we going to do with this? We have a shape here that's got a height of 6.4 feet. We know that one of the top lines here for that trapezoid on the bottom is 7 feet. That's the distance of that top line segment for that bottom trapezoid. And the side of that bottom trapezoid is 3.6 feet and then 9 feet. So what are we going to do? We're going to use our strategy. Let's split that shape. What I see here is, like I've been saying, a trapezoid at the bottom and a triangle at the top. So let's look at that again. A trapezoid at the bottom, a triangle at the top. So we're going to split that 4-sided shape into something that we can really work with. So our question now is, what is the height of the triangle at the top? Because we need that in order to figure out the area of that triangle. So let's do some math. 6.4, that's the height of the entire figure, minus 3.6, which is just the bottom portion, is going to give us what's left at the top, 2.8. Okay, so 2.8 is the height of that triangle sitting at the top. Now, we have just about everything we need to find that area. So let's go ahead and split these shapes apart. Now we can use our formulas. Let's look in our toolbox. The first shape, the first area formula we're going to need is the one for the trapezoid, height divided by 2 times base 1 plus base 2. The second area that we're going to need is the triangle, 1/2 base times height. So here we have it. Let's go ahead and fill in some blanks here. 3.6 divided by 2 times the quantity, 9 plus 7. Where is that coming from? 3.6 is our height for that bottom trapezoid. The base 1 is that 9 at the bottom for that bottom line segment. The 7 is the line segment length at the top. So 9 plus 7 is 16, and 3.6 divided by 2 is 1.8, and we have 28.8. Now let's go to the triangle. 1/2 times base times height, and where are we getting our numbers? 1/2 times 2.8, which is our height, and 7, which is our base. All right, so we have 1/2 times 19.6, and then there's 9.8. We put them both together, we get 38.65. feet squared. That's it. That's all you have to do for number 9. With number 10, we're looking at a really irregular hexagon. It's got 6 sides on it. What do we do with it? So to me, we're going to use the same strategy we've been using. We're going to split that shape, then we're going to find the area of the 2 individual shapes that we find. And at the bottom, I see a rectangle. At the top, I see a trapezoid. So those are the 2 shapes we're going to look at. So again, rectangle, here's trapezoid. And what we need to know is the height before we can figure out any areas. So let's take a look at our whole figure. We have 10 centimeters as the height for the entire figure. Then we have 6 centimeters for the height of that rectangle sitting at the bottom. Subtract those 2, 4 is the remaining length. So that has to be, that blue line has to be 4 centimeters. So now we have all the measurements we need. So let's go ahead and split that shape in half. We have our measurements. So now let's go to our toolbox. We need the area for the trapezoid and we need our area for rectangles. So let's go ahead and fill those in. The simple one is our rectangle. That's just 6 times 20. So it's A times B, length times width. 6 comes from here. That's our A. And our B, or our length, is 20, which comes from the bottom. 6 times 20 is 120. Now let's go to the trapezoid. The trapezoid's area is height divided by 2 times base number 1 plus base number 2. Here's where I'm filling in the blanks. That 4 comes from that height that we just figured out. The 20 comes from our bottom length, and that 10 comes from that line segment at the top. So we filled out the necessary measurements. So now it's 4 divided by 2 times 30. And 4 divided by 2 is 2. 2 times 30 is 60. All right, 2 times 30 is 60. And now we add up these 2 measurements. 120 plus 60 is 180 centimeters squared. And that's pretty much it for number 10. Y'all take care, and remember, math is not just about numbers, it's about the relationships that surround us every day. Have a good one.